There you are now. Welcome back to the workshop. So on today's episode, we're taking this cylinder head to the next stage. On the last video, we had measured the compression ratios. We had looked at how we would calculate compression ratios using the online calculator. We worked out what compression ratio we needed for the customer that is getting this cylinder head, and then we measured the depth that we needed to skim off the cylinder head in order to get the desired compression ratio. What is next to be done is the new bronze valve guides are to be fitted to this cylinder head. What I've just finished up, the operation I've just finished up there now, was machining the valve spring seat heights. Now, not the valve seat heights, but the valve spring seat heights. There's a video on the channel up in the right hand corner that shows you how to do that, or how it is that I did that. In the coming months we'll make an update to that video. There's a few more things I'd like to add to that, but it's a pretty in-depth tutorial. It shows you how I made my own cutter, which you can see here in the mill machine, and how I set depth, measure depth and use it. Amazingly, you know, it never ceases to amaze me. In fact, every time I go at one of these cylinder heads, how much differences there can actually be. There was probably 0.45, almost 0.5 of a millimeter difference between two of the valve spring seat heights here on cylinder 1 and here on cylinder 3. A massive difference between the two. The rest were close, but there was a big difference there. What that is doing is it's leaving you with a cylinder head where you've got uneven spring pressures across the cylinder head. You might think that that's a very little thing, but actually can have a huge effect to the smooth running and longevity of a valve train. So it really is worthwhile getting that done and doing it right. A lot of modern machine shops won't be able to do that for you because you'll already have your valve guides in. So it's well worth figuring out how to do that and doing that correct. The next thing to do is to install these bronze valve guides. These are a mini spares item. They come with a really good detailed instruction leaflet on how to fit them. The only thing that I've found over the years is that mini spares build these to a specification, which is probably to cover all bases, I imagine. I haven't had that conversation with them, but these as an item are a very good all-round bronze valve guide. However, on the inlet side, I would like to increase the taper, and it's something that I've been doing for the last few years, is to just slightly increase the depth of taper on the nose of the valve guide. What I find is when I put this valve guide in to the fitted depth I would like, the taper here doesn't come anywhere near where the combustion chamber, I'm sorry, where the inlet tract finishes. So you're losing valuable space there behind the valve where flow is required. So it's worthwhile just adding a little bit more angle. I understand not everybody has the access to a lathe like I do, so if you didn't, this would be more than fine. But it would be well worth, if you had a mate or you were friendly with your local machine shop, getting 4 of them done. Now the exhausts are perfect. There's no need on a standard cylinder head to do anything with the exhaust. They can be left as is. But the 4 for the inlet side are well worth adding that extra little bit of taper onto them and using them. So what we'll do now is we'll go over to the lathe and I'll show you that process, how it is that we add a bit of extra taper to these valve guides. I'm just setting the cross slide here at 9 degrees. What this gives us is it'll give the bullet a bit of a longer taper up the nose. I don't want to alter the dimension down here. So basically when I turn this back, I want to remove material up here on the guide, but not down here. So the aim basically is to take a few passes across the guide, extending the bullet nose up further, but not touching any of the space down here. This dimension is critical. You need a bit of meat down there on the guide in order to take heat out of the valve and keep all your valve train nice and strong and with a bit of go to it. So I'm going to operate the cross slide by hand here, and basically what I'll do is I'll bring the cross slide in until I'm pretty happy with it, and I'll take a few light passes and you'll see the taper starting to build up. Okay, so now hopefully you'll see the difference between what was the standard item and what I have done. So basically you can see that we have made the taper more gradual and coming further back up the valve guide. What this gives us now is you can see all that extra area inside in the valve guide that wouldn't have been there. So all that space in there, that extra space we've created, we've removed very little material but given ourselves more space. Space in that area is critical for flow across the valve, and it's a well worthwhile modification doing. Repeat that now 3 more times and then we'll be ready to start putting our valve guides into our cylinder head. Okay, all of those completed now, all 4 ready to go. I've deburred them, I have rounded over the end. One of the things I would just say to you guys is, the finish that I leave on these is 120 grit. Polish is not something you want here. If you have a really shiny surface here down in the inlet tract, it can actually knock the fuel out of suspension, and in an A-series motor that is definitely not something we want. So a slightly coarse finish here is actually a good thing. This notion of polished imported cylinder heads, polishing the inlet tract to a very fine polish achieves nothing other than a lovely look. It has no effect. In fact, sometimes it can actually be a downside to a good, well-performing cylinder head. Sometimes what happens is the fuel actually clings to the shiny surface and gets knocked out of suspension. So having a slightly coarse finish is not a bad thing. In fact, it generally tends to create a better airflow through the head. So fitting these, when I fit these guides into a cylinder head, let's just blow away some of these chips here. Just mind your ears, anyone who has headphones in. When we fit these in, I always like to put the cylinder head up here in the milling machine. The reason I do that is because the cast iron of the milling machine helps to give you a really hard surface to bang these on. Now, what I have is, I have the cylinder head standing up on aluminium blocks here, and that's to protect the milling machine and the cylinder head. So when I'm banging on the cylinder head to put these guides in, I'm not going to put myself in a position where I'm going to put dents into my table of my milling machine, or I'm not going to put dents into the cast iron of the cylinder head. So we're not banging 2 iron surfaces together. You can't actually see, but there is a third one in the middle. It's important to evenly support the cylinder head. It might look like a big solid lump of cast iron, but inside in the middle of the head is actually quite hollow. There's not a huge amount of iron in there. So you're banging on this to put in valve guides, and you could well crack or damage your cylinder head. So a well supported cylinder head on a very strong surface. If you didn't have a milling machine to do this on, I don't recommend doing it on a wooden bench. What I would say is, if you had something like some sort of a lump of iron, like a girder or something like that, would be good. A very heavy vise, anything cast iron that you can get your hands on, an old anvil or something like that, anything good and hard with loads of mass behind it. A concrete block could probably work if you put something like a sheet of aluminium over it just to protect the cylinder head, but again, concrete is not very dense, so it doesn't offer good rigidity. You want as much rigidity as you can when you're driving anything, when you're drifting anything. Now, talking about drifting, I have a couple of tools that I've made over the years to allow me to put in these valve guides. The one that I drive them out with, the keen-eyed amongst you will recognize as an old distributor drive. This is a distributor drive where this end got chewed up because someone didn't put the distributor into the engine right, and I suppose it probably could have been saved at some stage, but you know, when I made this, there was, you know, these were 10 a penny knocking around the workshop, so I wasn't too worried about it. But it's actually good material to make something like a drift out of, because it's just hard enough that it will drive without bending or distorting, but not so hard that you can't turn it into lathe on with a carbide cutter. So it's served me very well. I've had it for years and years and years, and I use it to drive out all the valve guides I've ever driven out. It just has two dimensions turned on it. One is the OD of a valve guide, and the other is the ID of the valve guide. So basically you've got a spigot that the valve guide can sit into, and then it can be driven by that. This is what I would call my starter. I pretty much only ever use this to drive valve guides out, but I can use it just to get started here, to get a valve guide going in. What I normally use is the chuck of the milling machine, just to press the valve guide in straight first to get it started, and then I drift it in afterwards with the hammer. I'm going to show you how I do that now in just a second. One thing that I'm going to tell you about when if you're ever going to make one of these for yourself, the profile in here is something to watch out for. That profile inside there, it's probably hard to see, but that shoulder is not 90 degrees to the edge of the pilot. In fact, the angle here is this way, so there's actually a dead space. You can just see the muck and dirt in there from driving out valve guides. There's actually a space in there, an undercut. The reason for that is very simple. When it's driving the valve guide, it's not driving the valve guide in that area in there. It's driving the valve guide on that outer diameter out there. And that's important, because if you drive the valve guide in here, you'll peen over the inside of the valve guide. And when you run your ream through, it may not take that shape properly. And you'll end up with a pinching valve guide, which can cause a valve to stick. And a valve sticking is not something that you want. So if we bring around the head of the milling machine here, and get ourselves set up, we can use this to help us start off or pilot our guides. So in a mini cylinder head, you've got you've got exhaust, inlet, inlet, exhaust, exhaust, inlet, inlet, exhaust. That's how it works, because it's a Siamese cylinder head. So the very first valve guide to go in is going to be an exhaust valve guide, which, like I said to you before, is just a standard taper. Okay, we'll do one of these here for you now straight off the bat, so that you can see what it is we're doing. So we'll lock the head of the milling machine, and we're using this just a bit like you might call it a I suppose you could say it's a arbor press or something like that. I just use that to get it started, all right, just to get the guide moving in a little bit. And if you can get a bit of movement on the guide, that's good. Then we'll drift it in the rest of the way with the next piece of tooling that I've made. Okay, that's our second one. We'll just move over our slide a little bit now, and that will allow us to get this second one in. So this is one of our fancy inlet ones. Now the cylinder head is just floating here, so that I can use it to allow me to get everything, you know, straightened up and right. You'll know if your valve guide's going in square anyway, guys, because if it's going in at an angle, it'll take a lot of pressure to put the valve guide in. And as you can see here, I'm not putting huge pressure on that valve guide. Again, there'll be another inlet then. So we'll walk the milling machine along. As I said, it's just floating on those aluminium blocks, which allows everything to square itself up, and we can get those guides moving in and started. The nice thing now is that we know all our guides are started and going in square and true. The biggest problem I come across when people try and drift in guides just with a hammer is that they don't get the guide in straight at the start. And if you don't get that guide in straight at the start, the result will be that you will end up with a valve guide that's moving out of place. Okay, all right, we'll continue on here, get the rest of these guys in, and then what we can do is I'll show you how it is that I finally drift the valve guides into height. The next part I'm going to show you is drifting these valve guides into their final height. This is a tool I've made up years ago. Very, very simple. You've got a setting ring and you've got a drift. The setting ring fits loosely over the valve guide, and the drift slides down into the guide itself. The idea is that you drive the valve guide until this drift comes in contact with the setting ring. You'll see that the drift can't pass through the setting ring. So once the drift comes in contact with the setting ring, you know that the valve guide is level with the cylinder head. I set my valve guides so that they are level with the top of the cylinder head and not protruding. The reason I do that, the factory was about 0.8, probably an eighth of an inch higher than that. The original factory height was, but using modern double valve springs and the caps that retain that, they stick down slightly further. With modern camshafts that lift much higher valve openings, what you can have happen is the valve cap can come down and pinch the valve stem oil seal, and it then in quick order destroys the valve stem oil seal, and then you start seeing an engine burning a little bit of oil. So it's much better to actually just sink them that small bit further into the cylinder head. Also remember that the valve spring seats have been cut, so dropping them down a little bit below the original height is no harm whatsoever. And thirdly, getting more engagement of the valve guide into the cylinder head is a good thing, because more heat can be taken out of the guide, which in turn takes more heat out of the valve and makes the whole operation more reliable. So drifting it in, nice simple process. I always make sure that my aluminium block sits exactly underneath the one I am, so that I'm not putting any bending forces or any bending motion on the cylinder head. Then with a hammer, a couple of good sharp taps, and you'll drive the valve guide down and into place. Minding the fingers, just driving it down, and you're just waiting for your drift. You can hear the noise change. That was the drift coming in contact with the setting ring, and that tells us that our valve guide is at height. You want to make sure that while you're doing this, that your hammer blows are straight down. Be very careful of hitting your hammer blow at an edge or a side. That can cause the drift to pick up inside the guide. It could also cause the guide to move off center. Using the milling machine or a drill press to put the valve guides in the first place has them sitting nice and parallel. All you want to do is follow that motion through. You can hear that noise changing. Tells us that we are where we need to be. It's not taking much force to put these guides in. I'm literally just tapping on this drift and the guide is working its way in. Okay, so I know there's people that are going to say you should be putting these guides in with a hydraulic press, or you should be putting these guides in with some sort of a machine or a tool. I've been drifting guides in like that into mini cylinder heads for at least 10 years, and I've never had ever a problem with a guide. One of the reasons I like to drift the guides in like that, I have a hydraulic press out there that I could use to put the guides in, but a hydraulic press, you have very little feel. You have very little sensation as to how that guide is going in. I have seen guides that were put in with hydraulic presses, and I've taken them out afterwards, and the guide has actually been broken inside in the cylinder head. The reason for that is because if the guide turns slightly while it's going in, well, if I'm drifting that with a hammer and a drift, I'm going to feel that immediately, because it'll go from that nice sensation of the guide moving underneath each hammer blow to the guide binding up. And at that moment I can stop, check, see what's going on, and reorientate. If you don't do that, if you use a hydraulic press or you use some sort of, winding it in with a threaded bar or something like that, it's going to be very hard to feel. The right way to do this is either drifting like that by hand or using something like a fly press. A fly press would be a good way of doing it. Unfortunately, I have yet to get my hands on a good one. Anyone wants to donate one to the workshop, we'd be more than welcome to take one. On that note, thank you very much to everybody who's tuned in today to watch the video. As always, I love hanging out in the shop here with you guys. Don't forget, if you're enjoying this content, just to bang that like button. It really does help us, helps get the videos out there and gets people watching. I just want to also say thank you very much for everybody who keeps tuning in. I know the videos aren't coming out as regular as they were a couple of months ago. Circumstances have changed a little bit. COVID changed things around here. Like I said, I'm back teaching. The garage is very busy. I'm trying to keep up with customer work, trying to make sure that I get some videos out for you guys, and also trying to have a tiny bit of a life as well among all of it. So I do really appreciate everybody's patience, and I know people have been eagerly awaiting videos, and some weeks we miss a video and some weeks we get a video or two out. So I really do appreciate your patience and understanding. Hopefully, as things are going over the next couple of months, we'll be able to get a bit more content filmed and we'll get a bit more stuff out for you. But for me, I'd rather give you good content less frequently than just banging out videos for the sake of banging them out. So hopefully you guys appreciate that, and it gives you guys better content. This stuff is the stuff I like doing with you. I like getting into detail and showing you stuff, showing you how it works in the shop. Speaking about detail, did anybody notice anything in the first clip when I was putting in the valve guides? We made a little boo-boo, I suppose you could say. Well, we made a little mistake. We started one of the exhausts, an inlet guide in an exhaust. We picked it up and took it out and put it back in again, but I'm wondering, did anybody spot it at the start? If you did, put it in the comments below. Alrighty, so next thing to do on this is to ream these valve guides, and then the valve train will be ready for its new valves to go in and to go off to the machine shop to get the seats cut. Okay, next job to do is to ream out the valve guides. Now, what is reaming out? You guys be familiar with drills. This is a twist drill, just picked a bigger one here to make it easy to explain. And what a twist drill is a means of boring a hole. It's two chisels opposed to each other, twisted around a center. These have cutting faces on either end at the front, and they remove chips of materials to make a hole. Because there's only two cutting faces, they do not make a particularly round hole. In fact, they tend to make an oblong hole, or an eye rather than a circle. The valve guide is what controls the valve and allows the valve to open and close. The valve is in the combustion process, meaning that a huge amount of temperature ends up in the valve from the combustion process. That valve needs to get rid of that temperature before it opens again, or else it'll be introduced to temperature again a second time, and the valve will heat up and up and up until such time as it either expands so much it'll get stuck in the guide, or the end will literally just melt off the valve. The way it gets rid of its heat is very simple. The guide is touching the valve, and it is taking the heat and sending it into the water jacket in the cylinder head. If you were to just simply push the guides into the head without reaming them, the valve may well fit into the guide. It may not. It may not go in at all, but it may well fit in, but it won't actually sit in such a way that all of the face of the valve stem is touching the valve guide. The less surface area of the valve stem that touches the guide, the less chance heat can come out of the valve. Now, I've seen people in the past run a 7/16 drill bit through valve guides. They run a drill bit down through the valve guide and say, that's the valve guide opened up, it's perfectly fine, the valve fits in it now, job's good. Not a good idea, because as I said, drills cut holes, they don't turn centrically. A ream, and I have loads of different sizes of them here just to show you, is a completely different thing. A ream, rather than having cutting faces up here like the drill bit did, here, has cutting faces along its edge. So each one of those is a cutting face. It's actually sharp along its edge, all along here. A ream is also concentrically ground, so that it is absolutely parallel and its diameter is accurate all the way along. Reams, however, can't take off big amounts of material. In fact, they become bound up and can get choked with big amounts of material. Typically speaking, a valve guide, when you buy it, is finished 2 or 1/1000ths, generally 2 to 3/1000ths under size. In other words, it's actually too small. Or it's finished such that when it's pressed into the cylinder head, it'll be undersized. Now, what we're going to do is, we have a 7/16 ream in the milling machine, which is the right size for the shank of a valve, and we're going to run the ream down through the guide. When I do this job, what I generally find is that the ream fits lovely here at the top, and if I put it through from the other side, it would fit lovely at the bottom, but in the center where the valve guide is sitting in the cylinder head, the ream will find material to remove, okay? And that is the really important reason why we ream. So I always start with the ream just slightly inserted into the guide. Never start with the ream running out of the guide, because if the ream has any run out at all, it's going to chew up the outside of your valve guide. So I always start with the ream just slightly in. It's a good idea to just give any thwart a blow off out of the way, and then liberally oil the ream, loads of oil on the ream. You can do this by hand, you don't have to do it in a machine like I'm doing it. I just happen to have the machine, so I use it, but you can absolutely do this job by hand. Next thing to do is to start the machine. I always run my reams slow. So typically speaking, about 200 RPM or around that is the speed I like to run my ream. You pass the ream through and you can see there it's just starting to find material. Now I have the head loose on the milling machine and I have the tables loose on the milling machine so that they can move around. What I want to happen is I just want the guide to remove the ream to remove the material in the guide and to come back up and out. Watch now when we stop, when we bring this ream out, there'll be material on it. Okay, so if I stop the machine now, you can see the material that ream has taken off. All this material here. That is what would have been making our guide tight, and what could potentially have caused us an issue where a valve guide might where a valve could stick or get tight. Now we get to try the valve in, and what we're looking for is a free moving valve. We want that valve to move up and down there freely without binding. This one probably still has a tiny little bit of stuff in there. Try a little bit of engine oil on our valve. And that's what I'm looking for. A valve that's running perfectly with its own weight. You can see it's fallen down into the ground. You can see under its own weight that it's fallen down, and that's exactly what we want, a nice free running guide. Believe it or not, if I pass that ream through that guide again, it would take more material off. So you want to be careful. You know, it's not about actually honing out the guide. You just want to get the guide so you've got that sliding fit. Remember, too loose a guide is as bad as too tight a guide, because it won't take heat out of the valve, and then again you can get valve failure again. So that is what I look for. I look for the valve to just be that lovely free floating. Without oil, that valve, you can see there now, just as the oil starts to get in there, the valve is starting to float, and that's exactly what we want. We want that valve floating. So that's a good fit. Right, that's our cylinder head ready now to go to the machine shop and get its valve seats cut. We'll send this cylinder head to the machine shop. They're going to skim off the amount of the cylinder head that we worked out in our compression ratio calculation, and they're going to seat all these valves by cutting new seats for the valves. The next time you see this cylinder head, it'll be back here in the shop, and we are going to set our valve springs up, set our valve seat pressures, and then coat of paint, and that cylinder head will be ready to go to the customer. There's a few repairs to be done to the cylinder head. We have a broken off stud here, and we also have a broken off waterway in here that needs to be plugged and knocked off. So we might get to that in the next video, get those few bits done and get the machining done for you guys, and get the cylinder head back and get the valve springs in and get the cylinder head off to the customer and make them happy. Thanks for tuning in and watching us. See you guys on the next one.